In this presentation, we're going to learn how to conduct a hypothesis test on the mean when we don't know the variance. And we're going to use the same example we used when we did know the population variance. That's conducting a hypothesis test of the lifespan of Boeing 747s that are currently owned by US Airways, excuse me. So basically what I'm going to do is I'm going to walk us through the process, and then we're going to go through the process via an example in Excel. So let's sort of talk about that process. So in this process, again, we are going to define our H0 and our H1, and that's not any different than what we've done in the past. We're also going to compute X bar, but now we're also going to compute S, which is our sample standard deviation. And that's different from when we did know the variance, because we didn't have to compute this S value. We were given the population variance, and we were able to compute the standard deviation using that. In this process, when the variance is unknown, we're not going to be computing Z0, which was our test statistic when we knew the variance, but instead we're going to be computing what we call as T0. And T0 is a test statistic that uses the student's T distribution, and using that we're able to compute our probability. And then again, we're not going to be determining whether or not to reject or reject or not reject the null using z at alpha over 2, but instead we're going to do it at t naught alpha over 2 at n minus 1, where n minus 1 are our degrees of freedom. And the reason why we have to do that is because we don't have all the information about our population that we've done in the past, and so we have to sort of reduce the degrees of freedom that we have when we're trying to determine whether or not to reject or not reject the null hypothesis. So let's go through this process a little bit more in depth. So recall that with our previous example, or for the previous presentation, we had Boeing 747s, and Boeing had reported that the mean lifespan was 24 years. And so what we wanted to do is we wanted to see what that meant for the US Airways 747. So we conducted a hypothesis test where we said, first, our null hypothesis, which said that the mean was equal to 24 years. So the mean of US Airway 747 lifespans was 24 years. Our next hypothesis is quite simply that it's not equal to 24 years. So now that we've defined our null hypothesis and our alternative hypothesis, the next thing we need to do is we need to go and compute X bar and S. So let's go and do that in Excel. So now that we're in Excel, you can see that we've put our mu, we'll call this mu naught, at 24 years, and we have a sample size of 10. So these were the lifespans of the reported 747, or a sample of the reported 747s owned by US Airways. So first we need to calculate X bar, and that's simply done by just taking the average of our sample, and we find that our average is 24.1. And the next thing we need to do is we need to compute our standard deviation. So in this case, we're going to use stdev.s because it estimates the standard deviation based on a sample, so not based on a population. And that's because we're only calculating the standard deviation based off of this sample that we have here. So we'll double click on that, select our sample, and with that we've calculated both X bar and S. So the next thing we need to do is we need to go in and we have to compute our T naught value. And T naught has its own special equation, just like z naught did. And in this case, the equation is x bar minus mu naught divided by s divided by the square root of n. So let me just change these here. So now let's go and compute T naught in Excel. So now we're in Excel, let's compute T naught, and again T naught is equal to x bar minus mu naught divided by s, or standard deviation, divided by the square root of our sample size. Oh. Sample size. Close up our parentheses, and we get a T naught value of 0.121566. So now that we have our T naught value, we're actually now able to go in and compute our probability and then ultimately go and compute our T alpha over 2 at n minus 1 value, and using that we can decide whether or not we're going to reject the null. So for probability, we have this probability can be computed via the equation of 2p of t n minus 1 is greater than the absolute value of T naught. And basically, this represents our random variable for our test statistic. And this is our T naught value that we've solved for up here. So in Excel, what we do in Excel is we actually use the t-dist equation, the t-dist formula. So you type in t-dist, and you can see here that it returns the student's t-distribution, and so in our case the student t's probability distribution, and it tells you the 3 things that we need to input. The first one is x, and that's our T naught value. Now, this is an absolute value, so if you have a negative T naught, make sure that you put your absolute value signs in here. In this case, we don't need to because our T naught value isn't negative. Next thing we need to put is our degrees of freedom, and our degrees of freedom is just n minus 1, which in our case is 10 minus 1. And then here it asks us what tails we're using. Is it one-tailed or two-tailed? So in our case, is it one-sided or a two-sided distribution? And it's a two-sided distribution based off of the type of hypothesis test we dictated. So we said that it was an equal or not equal type hypothesis test. As a result, it's a two-tailed. So in that case, we type in 2, and we return, and we get a probability of 0.091. So you'll see that we didn't actually multiply this by 2 as we dictated in our PowerPoint, which you can see here, that we had this sort of 2 value here. And the reason why we didn't multiply it is that we specify the tails there, and as a result, it sort of is embedded in the formula, so it does it for us. So the next thing we need to do is we need to compute T alpha over 2. So what we do there is we have an equation to calculate what our critical range is going to be, and that is equal to 2. So let me do this. So this is equal to 2 p t of n minus 1 is greater than 2 t alpha over 2 n minus 1, which is equal to alpha. So basically what we're saying is that at some alpha value that we specify, which again is either usually 0.05 or 0.01, we're going to be determining at what point, so here, where that t value is. So basically it's the value for which our probability of the random variable here, as dictated here, is greater than t alpha over 2 or n minus 1. So let's do that. So in Excel, to calculate what that random variable critical value is at our alpha here that we're specifying is 0.05, what we need to use is the TINV, and this is basically going to give us the inverse, so that again it's going to give us that actual random variable value for the student's t-distribution based off of a probability. And in our case, our probability is our alpha, which is here. So a probability, and then our degrees of freedom. So our degrees of freedom are n minus 1. And this tells us that our critical value is 2.26. So essentially what we need is we need our t naught value to fall within the range of negative 2.26 to positive 2.26, because that's our critical range. And in this case it does. And also our probability is pretty high. So in this case it's telling us that we do not reject the null, and based off of our probability and our confidence level. So I hope that you guys have a better understanding of how to compute a hypothesis test when we don't know the variance. Thanks.